Okay, so we will revise different types of bonding present since we have completed giant covalent, giant ionic, and giant metallic. So this video will give a good revision on these three things. So someone, she will represent. So let us start.
The three main types of bonding are covalent bonding, ionic bonding, and metallic bonding. Covalent bonding occurs when atoms share electrons, so their outer shells overlap, and they will share a pair of electrons. This only happens in non-metals, so metals are never involved in covalent bonding. There are two types of covalent bonding: simple covalent, which is small molecules like CH4, H2O, CO2 with just a few atoms in them. And this makes up most of the covalent compounds. So almost all covalent compounds are simple covalent. There are then a few exceptions, which are giant covalent compounds. Instead of small molecules, these have thousands of atoms joined together. They're still covalently bonded, but there are just a few of these examples that you need to know that form giant structures. Ionic bonding is not sharing electrons, it's giving and taking electrons. This happens when you've got both metals and non-metals together. You must have at least one metal and at least one non-metal. And when they react together, they form this giant ionic lattice of positive and negative ions. And finally, metallic bonding occurs only within metals, so non-metals are never involved. We've got the positive ions and their delocalized electrons. So we'll start looking at covalent bonding. Covalent bonding happens only in non-metals. So we never have metals involved in covalent bonding. And it happens when two non-metal atoms, or more than two, share a pair of electrons. So here we've got two chlorine atoms, their outer shells are overlapping, and they are sharing a pair of electrons. This shared pair of electrons is a covalent bond, and it joins the two atoms together. It's a very strong bond, and it holds them together. So this XO in the middle is a shared pair of electrons, and that is the covalent bond between the two atoms. This is a simple covalent molecule. We have the simple covalent, and we also have giant covalent. Simple covalent molecules are things like chlorine, Cl2, hydrogen chloride or hydrochloric acid, water, oxygen, and carbon dioxide. So you can see these are all elemental compounds that contain 1, 2, 3, maybe 4 atoms, but anyway, it's only a few. So when you've just got a few atoms in a molecule, that's a simple covalent molecule. Giant covalent, on the other hand, is when you've got many thousands of atoms joined together. 3 examples of this would be the allotropes of carbon, diamond, graphite, and graphene. Instead of just 3 or 4 carbon atoms, you've got hundreds or even thousands of atoms joined together in a giant structure. The one other example of this you need to know is silicon dioxide. You just need to remember these 4 examples. So if it's covalent, if it's not one of those 4 examples, you can assume that it's a simple covalent compound. Here are some practice questions for covalent bonding. Number 1, what is a covalent bond? Number 2, which types of elements form covalent bonds? And number 3, which of these compounds has a simple covalent structure? We've got sodium chloride, iron, diamond, sulfur dioxide, and oxygen.
Okay, so can anyone answer these questions? What is covalent bond? Afrin.
Can I give it a try? Oh, okay, that's fine.
It is an electrostatic force of attraction between a nonmetal and nonmetal where electron pairs are shared.
Okay, so it is an electrostatic force of attraction between nonmetals and nonmetals. But one thing, what I say is try to maintain the, try to say the definition in a way which fits your mark scheme. As I say, it is an electrostatic force of attraction between nuclei of the atoms. This is very important. If you mention non-metals and non-metals with shared pair of electron, it's not a correct definition. You will get 1 mark for that, because this definition in your IGCSE syllabus, they will give you 2 marks. And you must mention which one is positively charged entity and which one is negatively charged entity. Afrin, is it clear?
Yes, sir.
Yes, your definition is correct. non-metals and non-metals, they form covalent bond. That can be one definition, but for that definition, you are not going to score marks, right? So what they want, what your syllabus want is, or your mark scheme want is, it is an electrostatic force of attraction between a positively charged entity and a negatively charged entity that you mentioned. So that is how you need to say the definition, number one. Number two, which type of element form covalent bonds? Iftikhar. Iftikhar boy, nice. Very good. Fida, what types of element form covalent bonds? Fida.
Yes, sir.
Yes. What type of element form covalent bonds?
What type of element?
এই যে লেখা আছে এখানে দেখো পড়ো তুমি
Oh, what type of element form? Wait, sir.
Fida, you there?
Wait a minute, sir.
Sir, non-metals.
হ্যাঁ ঠিক আছে কৃতিকা, ও অনেক টাইম নিয়ে নিতেছে। আচ্ছা ঠিক আছে। নাম্বার 3, which of these compounds has a simple covalent structure? Who will tell this? Sunny Ryan.
Yes, sir.
Yes. Number 3, you answer please.
Which of these covalent has simple covalent structure? Simple. Except diamond, all of them, I guess. Sodium chloride, sulfur dioxide, oxygen.
All of them are simple covalent. Sodium chloride is simple covalent. Sir?
Iron or oxygen, sorry, oxygen.
Sodium chloride is what type of compound is sodium chloride? Ryan?
It's not a covalent.
Is it covalent? It's metal and non-metal. Sodium is a metal and chlorine is non-metal.
It's oxygen, the simple covalent structure.
I'm asking regarding you try to understand my question. Sodium chloride, is it covalent or ionic?
It's ionic.
Ionic. Why? Because it is metal and non-metal.
Metal
In
and non-metal.
covalent substance, there cannot be any metal present. There can be only non-metal. Iron, what is that? Covalent.
Metal.
Iron.
It's only metallic.
Metallic. Very good. Diamond.
Carbon.
Right. Diamond, carbon, fine. Diamond is made of carbon. But what type of structure is this? Giant covalent, simple covalent, giant ionic.
Giant covalent. Giant.
Giant covalent. Very good job. And sulfur dioxide.
Sulfur is metal, metallic.
Sulfur is not metal. Sulfur is non-metal. If you look at the zigzag line, sulfur is right-hand side of the zigzag line. It's in group 6. Okay, sulfur is non-metal, oxygen is non-metal. So it's non-metal and non-metal bonded together. So it is definitely not diamond, not graphite, not silicon dioxide. So it is definitely a simple covalent. And oxygen is also simple covalent. Fine.
Okay.
Aman, is it clear?
Yes, sir.
Okay, very good job. So let us proceed.
Pause the video and have a go at these questions.
Yes, we have paused and we have
Shared
paused.
pair of electrons. It's a pair of electrons that are, so in this diagram bond, in element non-metal covalent, whereas sulfur dioxide,
Okay,
and
it has
because they're,
a
which is a little bit different to covalent bonding.
okay, ionic bonding.
Now we're going to look at ionic bonding, which is a little bit different to covalent bonding. This happens when you've got both metals and non-metals. It won't work unless you've got at least one of each, metals and non-metals reacting together. And this time, instead of sharing electrons, they gain electrons and lose electrons. So here we've got a magnesium atom, which has lost 2 electrons. So it's formed a magnesium ion with a 2+ charge, a positive charge. That is our metal ion. And then we've got an oxygen atom that has gained 2 extra electrons to form a negative oxide ion. And that is our non-metal. So we've got a metal and a non-metal reacting together. Because one ion is positive and the other is negative, there'll be an attraction between them. And that attraction is our ionic bond. So So the definition of an ionic bond is a strong electrostatic attraction. That is a really, really important key phrase. That just means attraction between positive and negative. And in this case, it's between positive ions and negative ions. So we have our positive and negative ions arranged like this in this big crystal structure. And this would happen thousands and thousands of times over with thousands of atoms. And there's that attraction between positive and negative ions. That is your ionic bond, that strong electrostatic attraction. This structure where you've got thousands of ions repeating in that structure is called a giant ionic lattice. Some examples of ionic compounds will be calcium chloride, magnesium oxide, and aluminium bromide. So you can see in each of these chemicals, if you look at their formulas, we've got a metal and a non-metal. So calcium is a metal, whereas chlorine is a non-metal. In magnesium oxide, magnesium is a metal and oxygen is a non-metal. And in aluminium bromide, aluminium is a metal and bromine is a non-metal. So you can see in each case, we've got both a metal and a non-metal element present, at least one of each. You could have more than one of each. It will not be ionic bonding unless you've got both a metal and a non-metal present. Here's some practice questions about ionic bonding this time. So number one, what is an ionic bond? And note this one's a 2-mark question. Number two, which types of elements form ionic bonds? Number three, which of these compounds are ionic? There's just one in this case. We've got sodium chloride, iron, diamond, sulfur dioxide, or oxygen. Pause the video and have a go.
Okay, so what is an ionic bond, Ayman? Ayman, you there? Ayman?
Yes, sir. Yes, sir.
Okay, can you answer what is an ionic bond?
Sir, it is an electrostatic force of attraction between oppositely charged ions.
Very good, exactly. 2 marks, huh? Between cations and anions, you can say, or oppositely charged ions. Very good job. So 2 marks you will get for this definition. Number two, which types of element form ionic bonds? Can you answer?
Metal and non-metal.
Chemical compounds.
Which type of element? Metals, non-metals, only metals, non-metals, non-metals. What type of element form ionic bonds? Ayman? Covalent, only non-metals. Ionic, metal and non-metal must be present. Metal will give in the donate electron and non-metal will accept electron. Metal will form cation and non-metal will form anion after electron transfer. Fine, Ayman? একটু খেয়াল রাখতে হবে এটা.
Yes, sir.
Okay, number three, Kritika, which of these compounds is ionic?
Sodium chloride and sulfur dioxide.
Sulfur dioxide is not ionic, Kritika. Sulfur dioxide is, sulfur is a non-metal and oxygen is also non-metal.
Sodium chloride.
Only sodium chloride. Only sodium chloride here. Okay, very good job. Fine.
That's the right side a sample of a metal. And this
Show
happens.
the last one, metallic bonding.
The last type is metallic bonding, and this happens obviously only within metals. So it happens inside a sample of a metal or between metals. The metal atoms lose electrons out of their outer shell, and that makes them form positive ions. Between them, just like with ionic bonding, they're going to be attracted to each other, and this attraction between the ions and the electrons is the metallic bond. So the definition of a metallic bond is a strong electrostatic attraction. So it's the same key phrase as with ionic bonding, but this time, instead of between positive ions and negative ions, it's going to be an attraction between the positive ions and those negative delocalized electrons. And that attraction holds the metal together and it helps it keep its structure. The positive and negative are attracted to each other and that holds the metal together. This is what this giant metallic structure would look like. So again, in this case, just like ionic bonding, you've got many thousands of atoms joined together in rows, forming this giant metallic lattice, being held together by that attraction between the ions and the electrons. So examples of metallic substances would be magnesium, calcium, aluminium, copper, sodium, and iron. So things that are on the left of the periodic table. And some final practice questions for metallic bonding. Number 1, what is a metallic bond? Number 2, which types of element form metallic bonds? And number 3, which of these compounds is metallic? Pause the video and give these questions a go.
Okay, so who will answer? Ifat. Ifat. Ifat, you there? Hello.
Yes, sir. Yes, sir.
Okay, fine, you are there. Can you answer what is metallic bond?
It is electrostatic attraction between positively charged metal ions and conduction electrons.
Delocalized electrons. Delocalized electrons. Positively charged metal ions and delocalized electrons. Very good job. Number 2. Ifat, number 2. Hello, sir. Ifat.
Yes, sir.
Number 2. Tatari bolo felo. Which type of element form metallic bonds? Which type of element form metallic bonds?
Sir, I'm believing.
Metals only, metals. Ifat? Metallic bond cannot be formed by non-metals, right? Only in a metal you will get metallic bond. ঠিক আছে?
Yes, sir.
Okay, number 3. Which of these compounds is metallic? Ifat, first. Which of these compounds are metallic? Turn on your mouthpiece. Keep on
Third.
turning.
Diamond.
Diamond is metallic. I'm afraid you are not doing classes, online classes properly. You are not attentive. You are not working at home. Ifat. I'm going very slow, and I know I'm explaining it well. ঠিক আছে? So তুমি খুব ভালো করে দেখতেছো না, because it's online class. আমরা হচ্ছে স্টুডেন্টদেরকে দেখতেছি না. So we don't know what is the condition of each student. So if you cannot answer this question, it means you are in trouble. You are not giving full effort. So please try to give full effort. Diamond is giant covalent, that you must understand. Diamond and graphite, they are giant covalent, right? And diamond is made of carbon, and carbon is a non-metal. We have said you the zigzag line, and it's right hand side of the zigzag line. Carbon is in the right hand side of the zigzag line. Okay, so Ifat, what is the metal here? Say only one metal is present. Which one? Ifat?
Sir, iron.
Iron, only iron. Sodium chloride is ionic, diamond is giant covalent, sulfur dioxide is simple covalent, oxygen is simple covalent. So only iron is the metal. So see, I'm going very slow. I say, for some students, maybe it is a bit disturbing. Just sir, you are going very slow. But still, even they are disturbed, for the benefit of all the students, I will go slow initially. So I'm going slow because of all of you. I want all of you to be very strong. So if you don't help me, then later on when I will be fast, you cannot reach me, I'm saying. Only the students who are following this patiently, they can reach. I will go fast, right? We need to finish the syllabus. We have many chapters left. Although we have finished some, but we are slow. And for you, we are slow. So go back, sit on the table, study properly. If you miss any lectures, then go back to the YouTube video, finish those lectures, work with the end of chapter questions. These are the things you need to do. So that is it. The other book, if you look at the other book we have posted in the Google Classroom, it's page number, it's basically chapter 4. Chapter 4 is done. See, the same thing is written, explain some key properties of metals. Metals usually have high melting point. The same thing is explained. Metals are malleable and ductile. Metals are good conductors of heat and electricity. Metals are good conductors of electricity. So electricity, good conductors of heat and electricity is the same thing. So the same thing is discussed here. Checkups on chapter 4C. This thing you should do at home. Page number 64 from that. Wait, just 2 minutes. Give me 2 minutes. I'm coming. After 2 minutes, it will be 4. So we can complete the discussion here. So go back, look back. As I said, this chapter is already done, chapter 4. And from that chapter, from that book, I have said you to do stuff. So you work out from whatever book you do, no problem. You work out. So it will be the same thing in all books. So you can do. So that is it. So এটা আমাদের শেষ হলো আমরা states of matter and particulate nature of matter will start in the next class inshallah. Thank you.
Bye, sir.
Assalamualaikum, sir.
Thank you.